So in this part of section 4, we are no longer restricted to our unit circle. So on tonight's homework, you shouldn't really need your unit circle as you're working on the homework, but I would definitely like set aside a little bit of time, to quiz yourself over the unit circle so that you're looking at it every day. We want to find trig functions of any angle. What we do for today should seem very familiar to you from whichever class you took last year, whether that be Algebra 2 or Algebra 3. You should have seen the same definition on my next slide in that class. So first, we're going to just talk about the definition. The trig function of any angle. We're going to let theta be an angle in standard position with the ordered pair xy as a point on the terminal side of theta. And r will be equal to the square root of x squared plus y squared. I'm going to use the drawing to help us see why that is, okay, and what we're talking about. Okay, so if I were to pick any angle in standard position, it could be an angle with terminal side in quadrants 1, 2, or 3. I'm going to go ahead and draw an angle in standard position so that its terminal side lands in quadrant 2. Okay. And somewhere on that terminal side is a point, xy. And that's the point we're going to be working with. Okay, we know that specific point somewhere on the terminal side. It could be further away from the origin or closer to the origin. Okay, it wouldn't really matter. You could treat that then as like the radius of the circle, the distance from 0, 0 to xy. Okay, and so using this point, we have some angle theta right here. And we want to calculate the sine, cosine, and tangent of that angle theta. But as you look at angle theta, if I put it in the quadrants 2, 3, or 4, theta is actually larger than 90 degrees. So we couldn't form a regular right triangle with the angle theta because it's too large. So this is where that idea of a reference angle comes in from yesterday. If we were to draw the reference angle here in quadrant 2, we would use the terminal side and the horizontal x-axis. So we'd have a reference angle and call it theta prime right there. And that is an acute angle in the right triangle formed if we drop a line perpendicular to the x-axis from the point xy. Okay, so I'm creating a right triangle with the reference angle of theta. And when you calculate the sine, cosine, and tangent of the reference angle, you are effectively calculating the sine, cosine, and tangent of the original angle. So in this triangle, I can label the sides. To get from the origin to that ordered pair, I have to go x to the left and y up. Now I know x in that quadrant must be a negative number, and I know y must be positive, but I don't have to label it negative x. It's just whatever x is. Okay? And so you could think about in terms of right triangle trig, if you knew one leg of your right triangle was x and the other leg of your triangle was y, how would you find the hypotenuse? Pythagorean theorem, right? So you would say, if we called that like the radius, we would say x squared plus y squared is equal to r squared. Okay. And then to find that value of r, we would just take the square root of both sides. So that's where this piece comes from. No matter which quadrant I'm in, I'll always draw the right triangle the same way. It'll have one leg x, one leg y, So to find the missing hypotenuse, I'll do x squared plus y squared and take the square root of it. So you can decide as you work through problems, are you going to think about it more as from the geometry perspective with the right triangle in Pythagorean theorem, or are you going to think about it more as like a pattern, this will always be true, so I could just do r equals the square root of x squared plus y squared. Okay, that's up to you. But once you have all of those sides labeled, so this side is r, then you are able to calculate the 6 trig ratios on that triangle. Remember, we are actually doing theta, the larger angle that has a terminal side in quadrant 2, but it will appear in the right triangle if you look at it visually like you're calculating sine, cosine, and tangent for theta prime. That's its reference angle. They have the same trig ratios. Okay. So the sine would be listed as what? Sine is y over r. Okay, we're thinking about opposite over hypotenuse. Cosine is x over r, and tangent is y over x, which tangent is just like it was for the unit circle. Why do I have over r instead of just y and x for sine and cosine?
Because the radius isn't always 1.
Okay, we are not guaranteed that this is actually on the unit circle, right? This is any angle. It could be an angle that's not on the unit circle. So I don't know if the radius of this is 1 or not. Okay, so technically these are the same definitions for the unit circle, but on the unit circle, r is equal to 1, so we could say sine is y, cosine is x. Okay. Then you could also write out cosecant by just writing the reciprocals. Notice that if your angle was in the second quadrant, like mine is drawn, remember I said, I know my x has to be negative there, and my y would be positive. If you were to then plug in for y, x, and r, you would have a positive sine, a negative cosine, and a negative tangent because of the negative x, which that fits the rule of the second quadrant, that only sine would be positive. So all the things that we know about trig ratios around the coordinate plane remain true using this definition. So I'm going to give you a slide. I'm going to show you an example, and I'm just going to let you kind of like brainstorm what you might do. And there are multiple avenues you can take to get to the right answer. Some people will think about it visually, and others will just think about it in terms of definition. Okay? So here's your first example, something similar to what you might be asked on your homework assignment. Let negative 2, 3 be a point on the terminal side of theta. Find the sine, cosine, and tangent of theta. So the objective of this question is to be able to get the three basic trig ratios, sine, cosine, and tangent. As I'm walking around the room and kind of looking over your shoulders, I see two main ways people have approached the problem. One of them is just from that definition that we just wrote down. Okay? So people are looking at it like from that definition that we just wrote down, we know sine is y over r, we know cosine is x over r, and we know tangent is y over x. So when we get an ordered pair, we immediately have x and y. In order to be able to do all three trig ratios, we would also need r. So I've got some people who are just jumping right into that definition saying, I know every time I calculate the radius will be the square root of x squared plus y squared. In this particular instance, it will be the square root of 13. And once you have x, y, and r, you're ready to do your three trig ratios. Sine is y over r, cosine is x over r, and tangent is y over x. You'd have to rationalize your denominator for sine and cosine, so we'll come up with 3 square root 13 over 13, and negative 2 square root 13 over 13. But what's nice about that definition is it has taken care of like all of the sign issues that I would have, right? Sine is positive in quadrant 2, cosine and tangent would be negative in quadrant 2, and the ordered pair negative 2, 3 falls in quadrant 2. The other approach, which I think is a really great approach, especially when you're first starting this out, is rather than just jumping from x, y, and calculating r, and not really seeing it, I saw several people start with a picture, which I kind of like in the beginning because I think it kind of cements that definition for you. So the point negative 2, 3 is somewhere in the second quadrant, and then you can think about it like a right triangle. And so then you know to get to that point I had to go negative 2 to the left, 3 up. You'd still calculate radius, either with Pythagorean theorem or our shortcut rule, and you would get square root of 13. But now maybe you can see more clearly why the sine is y over r. It's opposite over hypotenuse, 3 over square root 13. And cosine and tangent follow from that. Okay? So if you prefer a more visual approach, certainly draw that triangle. I kind of like that for the first few problems that I do, just so that I kind of remember why those rules are what they are. Y over r, x over r, y over x. And that works in all the quadrants. Okay, next example. The cosine of theta is equal to 2 over 3. So I'm giving you 1 ratio. The tangent of theta is greater than 0. Can you tell me what cosecant of theta is? So I'd like to kind of walk through this one together so that we can kind of give each other some ideas here. When you write out that problem, what kind of information am I providing you with? By telling you the cosine of theta is 2 over 3 and the tangent of theta is greater than 0. What kind of information can you pull from that? Callie says you have x and r, right? The definition of cosine is x over r. Okay, so I could certainly label this is x and this is r. Great. With x and r, could you find y? Yeah, I mean, essentially, I would probably plug it into r squared equals x squared plus y squared. Okay. And then I would have like 3 squared equals 2 squared plus y squared. So I get down to 9 equals 4 plus y squared equals 5. What is that? Why is the tangent of theta greater than 0 important?
So we know it's not like a straight line. The tangents. So we know the tangent is not undefined.
Well, the only way the tangent could be undefined is if cosine were 0, because then it would have to be like, even if it weren't on the unit circle, it would have to be on the vertical axis, right? So your cosine would be 0. To tell you which quadrant it's in. Okay, so think about this. Cosine is positive, tangent is positive. What quadrant are you located in? Quadrant 1. Okay, so we have to be in the first quadrant. And that would mean, like, when I drew my right triangle, okay, my point was somewhere over here. Callie had told me the radius was 3 and the x was 2. I went 2 to the right. But you really could have been, to create a right triangle, you could have then gone up or down, right? So the tangent of theta being a positive number is what tells me that my y value, and notice I stopped right there, y must be a positive square root of 5. If I had said that the tangent was negative, or the tangent was less than 0, you would know that your triangle would have to show up in the fourth quadrant, so that cosine was positive, tangent was negative. And then when you solved for y, you would have actually said y was negative square root of 5. So that's a little bit different than what would happen in like a geometry Pythagorean theorem, right? In geometry, it would always be positive, because it would represent the side length of a triangle. In algebra, in trigonometry, and pre-calculus, we can label it as a negative because it's telling us a direction. We're actually going down square root negative, or square root of 5. Okay, so this tells me it's positive, and then I can use that to find my cosecant. Okay, so my cosecant of theta would be the reciprocal of opposite over hypotenuse. So it would be hypotenuse over opposite, or r over y. Okay, 3 over the square root of 5, which I would have to rationalize 3 square root 5 over 5. Since it's in the first quadrant, it should also be positive. Okay. But you'd really want to pay attention to if you were located in a different quadrant. Okay, that might affect the sign of your answer. Sign, positive or negative. Okay, so see if you can use that to kind of do this last one for me. See if you can come up with, really I would say the thing you've got to push yourself here is, are you identifying the triangle in the correct quadrant? Okay. So that you get the right signs for your trig ratios. You know that the tangent of theta is negative 4 over 7 and the sine of theta is less than 0. Get me the secant. What quadrant must we be in? Lillian says quadrant 4. Anybody second that? Lily seconds it. Okay, so must be in quadrant 4. labeled that wrong, didn't I? Tangent. Whew, it's crunchy. This is y over x, yes? I did it. Callie's like, you can do it, Miss Cronky. Thank you. I appreciate your support. R equals the square root of 49 plus 16. Did you get the square root of 65 for your radius? Okay. And note that radius will always be positive. X and y could be positive or negative, okay, depending on where they are on the coordinate plane. But r is always a positive number, okay? And then to do the secant of theta, theta is always centered around the origin right there. So we'd be doing hypotenuse over adjacent. Square root of 65 over 7 should be positive because we're in the fourth quadrant. Any questions there? Okay, lots of things to think about, but lots of ways for you when you get your answer to check your answer if it makes sense. Like, is it the right sign, positive or negative, for what quadrant I would be located in? Okay. You have a homework assignment. It will be your last homework assignment that I'm coming around to check before your quiz on Friday. Tomorrow you will receive a review for sections 4.1 to 4.4. You will also receive your first problem set for the semester, which has a one-day turnaround, so it'll be due on Friday. If you've been keeping up with homework, shouldn't be too terrible. The problems don't take that long to do, and I'll give you more directions on that tomorrow.